All right. So what we have here is we're going to be working with inequalities still, but we have significantly more options. Our answers are going to be in that interval notation, but we have like weird quadratic-y things. So what we're going to do is we are going to find the zeros, because we know that's where things are going to start being weird. So find the zeros for if this was 3x plus 1 and 5 minus 10x equals 0. Find our zeros. So what are our zeros going to be here? Negative 1/3. So if this equals 0, x equals minus 1/3. And if this one was 0? No, yeah, subtract 5 from both, not negative. Subtract 5 from both sides, divide by negative 10. X equals 1/2. Okay, so find those zeros. No, that's not it. Nice try, though. Because what we're going to do is we're going to kind of draw that on a number line. We're going to have two really important things happen at our zeros, where x is negative 1/3 and x is 1/2, right? Because if I need this thing to be bigger than 0, what kind of number does it need to be?
A positive.
Positive. So I don't really care what the value is, just whether or not it's positive, right? So what we're going to do is we're going to look at each of these pieces and see when those pieces are going to be positive or negative. And we know that the zeros are going to be kind of important pieces on that. So I'm going to look at 3x plus 1. And I gave myself very little space here. If x is less than negative 1/3, so what is a number less than negative 1/3? Negative 1. Way easier to think about. If x was negative 1, is this going to be positive or negative?
Negative.
Negative, because 3 times negative 1 would be negative 3 plus 1, right? And that's going to be true for anything less than negative 1/3. So this chunk is going to be negative. Did I hear what, or was it a yawn?
No, it's
Okay, cool. Just checking. I'm just looking for whether or not the piece is positive or negative. So what's something between negative 1/3 and positive 1/2? 0. If x is 0, is this positive or negative? Positive. So I'm going to put a plus. If x is bigger than 1/2, is this going to be positive or negative? Positive. Yeah? Just for funsies, right? Okay, so we're going to do the same thing with the other term. I'm going to do this in real quick. 5 minus 10x, because I need to write it really small to give myself space. There we go. Our 5 minus 10x, our other term from up there. If we have a number smaller than negative 1/3, is this going to be positive or negative? Because smaller than negative 1/3, negative 1 was the one we used before. Yeah, because negative 10 times negative 1 is positive, plus 5, positive. If I plugged in, say, negative 1 into this chunk, 5 times negative 10 times negative 1, we'd get 15 right there, right? Which is positive. Yes, dear? I promise I will show you. We haven't gotten to the y yet. We're just kind of doing, because I told you to. We'll get to the y in just a second, I promise. Right now it's just following orders. Okay? The y comes in the very next step, I promise. So if this chunk, if we use the in-between, negative 1/3 and negative 1, or and positive 1/2, sorry. If I plug in, remember 0 was in between, right? Is this positive or negative? Positive. If we pick something bigger than 1/2, negative, right? We still haven't discussed the y yet. Because remember, this piece times this piece needs to be bigger than 0, right? Which means this piece times this piece needs to be positive. We need this piece times this piece to be positive. So what we're going to do is we're going to see if I multiply together the two pieces, are we going to get a positive value? A negative times a positive. Is that positive or negative? Negative. A positive times a positive. A positive times a negative. So where are our solutions going to be? In the middle. So the solutions to this inequality are in this piece right here. Yes. Are negative 1/3 and positive 1/2, are they included or not included? Not included. So our solution is going to be parentheses negative 1/3 to 1/2. Yes, dear. Are we multiplying the 2 at the top? Mm-hmm. So we find our zeros. We look at each segment to see if it's going to be positive or negative on either side of that 0. And we use that to figure out where the product is going to be. Okay? We're going to do another one of these now that we know what the heck we're looking at. Maybe it'll make a little bit more sense. That's just a barrier so that we can tell the two problems apart. We start with where are our zeros? So on this one, where are our zeros? -2, +1, and +4. So I'm going to draw my little number line. Smallest to biggest. -2, 1, and 4. We're going to look at each of the terms and figure out where it's positive and where it's negative. So x plus 2 is my first term. So if we have numbers that are smaller than -2, is this going to be positive or negative? Negative. If we have numbers between -2 and 1, is this going to be positive or negative? We should never have a time when we say both. So pick a number between -2 and +1. 0. 0 plus 2. Positive. If you wind up with a segment where it's both, double check your zeros because you should never have a segment where any of the pieces is both positive and negative. Okay? If we have a number between 1 and 4, is this positive or negative?
Positive.
If we have a number bigger than 4, is this positive or negative? Positive. We're going to do the same thing with our other factors. X minus 1. So if it's smaller than -2, is this positive or negative? If it's between -2 and 1, is this positive or negative? X minus 1? Because if we use 0 minus 1, -1. Or -1.5 minus 1, negative. -0.9999999 minus 1, still negative. If it's between 1 and 4, positive. If it's bigger than 4, positive. All right. We've got one more factor here. 4 minus x. So if we're subtracting a number bigger than -2, or sorry, -2 or less, from over here.
Will it be
Positive. It is positive. 4 minus something here.
positive?
4 minus something here. Positive. And 4 minus something bigger than 4.
Negative.
Negative. So then we're looking at the product of all these pieces because all of our terms are multiplied together. Negative times a negative. Oh, it helps if I point for you. Negative times a negative times a positive. Positive. Positive times a negative times a positive. Positive, positive, positive. Boom. And positive, positive, negative. So then we look back at our original equation. Do we want it to be positive or do we want it to be negative? Less than or equal to 0?
Negative.
We want it to be negative. So we need it to be negative. Are our zeros included? Can it equal 0? Yes. So we know it's this piece and this piece. So from -2 to 1, inclusive. And we're going to draw a U for union. And then 4 to infinity. Is that a little clearer now that we know why we were doing those little steps there? Because I know the first one is very much, until we see everything. Hopefully the second one makes it a little clearer. Because we're going to do more of these because we're not always going to hand them to you in factored form. Oh, snap. Yay! I know, everybody's favorite. All right. Ready for me to change it? All right. I heard no. All right. Here's the next two. We have x squared minus 2x minus 5 is greater than 3 as our first one. What's up? For the other one? Yep, that's what we do next. So before we start trying to hop into anything and start trying to just like jump into factor, it's not going to be easy to tell whether or not it's greater than or equal to 3, is it? It's really easy to tell when things are positive versus they're negative. So make it do that. Make it equal 0. Just like when we were factoring, we'd always make it equal to 0. Same thing with the inequalities. Subtract 3. That's going to give us x, come on, pen, x squared minus 2x minus 8 greater than 0. Factor it. Multiplies to make -8, adds to make -2. Yes, you can. -4, +2. My a value is 1, so I do not even need to use a box or grouping. We get x minus 4, x plus 2 greater than 0. And we are into exactly what we did on the previous page. We need to find our roots first, or our zeros. Yep, x equals 4 and x equals -2. So I'm going to put those on my little number line. And I'm going to remember to give myself space on the left this time. So my smaller one is -2. My bigger one is 4. That is the diagonaliest number line ever. But you know what? It's all good. It gets the point across. Give myself some more space. So then we're going to take each of our terms. We're going to figure out where it's positive and negative. X minus 4. Really bad at straight lines today. If it is smaller than -2, is this going to be positive or negative? Negative. If it's between -2 and 4, is this positive or negative? Pick a number between. So number between -2 and 4. 0. 0 minus 4. -4. Negative. Okay? That's why I always put it on that number line. Every single time I'm going to draw that number line. It's way easier to spot it with that number line there. I know it doesn't feel like it makes that much of a difference, but I promise it does. All right, so if it's a number bigger than 4.
Positive.
Positive. So I'm going to take my other term, x plus 2. If it's a number smaller than -2, is this going to be positive or negative? Negative. Negative. If it's a number between -2 and 4, is this positive or negative? If it's bigger than 4, positive. So then we're going to look at our product. The product of those two. A negative times a negative, positive. A negative times a positive.
Negative.
And a positive times positive.
Positive.
Are we looking for a positive or are we looking for a negative? Positive, because x is, so the product is supposed to be greater than 0. So our solutions are this piece and this piece. Are our zeros included? No. So we have from -infinity to -2. Everybody's in parentheses because it's not included. And we have from 4 to infinity. And we draw a U between them because it's the union of those two sets. So there's that whole one. Okay? Same process. Make it 0. Make 0. Which means we're going to have to do a couple of things on this next one. We're going to distribute. Exactly right. Because we're going to have 2x squared plus 3x minus 5 is greater than or equal to 0. Make it equal 0 first, then factor to see what we can do. Because I want to see a pair of numbers that multiplies to make -10, adds to make 3. 5 and -2. I have an a value. Do not just put this straight into x minus 5 or x plus 5x minus 2. So we're going to have 2x squared minus 2x plus 5x minus 5 greater than or equal to 0. I do it this way so that I can do my factoring by grouping. You can do whatever floats your boat. We should wind up with 2x plus 5 and x minus 1. like that. However you choose to factor is up to you. Bring it in. You okay on the factoring part? You can always box it if you're more comfortable with the box. Oop. Coffee on my fingers to make sure I'm taking out. There we go. From here, we find our roots or zeros. Where are our zeros? Yep. So if this chunk, if this chunk equals 0, we subtract 5 from both sides and then divide by 2. And our other one is 1. So when we draw this on our number line, the smaller one is our negative 5/2. Our bigger one is 1. So we're going to look at all of our pieces. 2x plus 5. If we pick numbers that are smaller than negative 5/2, are we going to have a positive or a negative number? Negative. If you pick, just like when in doubt, pick something smaller than negative 5/2, negative 3 or negative 4. 2 times negative 4 gives me negative 8. Negative 8 plus 5, definitely negative. When in doubt, pick a value and plug it in. Absolutely valid. What about something in between? 0 would be a fine one, so it's going to give you positive. Something bigger than 1, positive. Then we'll do our other term, x minus 1. Something smaller than negative 5/2. Are we going to be positive or negative? Negative. Between negative 5/2 and 1? Negative. Bigger than 1? Positive. So when we look at our product, positive or negative? Positive. Positive or negative? Positive or negative? What's our goal? Are we looking for positive or negative? We're looking for positive. This needs to be bigger than 0. So this is our solution and this is our solution. Are our end pieces included?
Oh, yes.
Yes. So we can go from negative infinity, which always has a parenthesis because infinity is an idea, to negative 5/2 included, bracket, union with, bracket, 1 infinity, parenthesis. Okay. How are we feeling? Goodish. I'm good with goodish. It is about to kick up a notch. This is 2-7. This is the last bit. And what we're going to do next is the same as pretty much what we're going to do tomorrow. So this is like the notch. This is the hardest it's going to be. Are these? Don't panic, don't panic, don't panic. I promise, don't panic. This is still 2-7. This is still inequalities. All right? This is 2-7. This is 2-7. This is as hard as it gets, are these guys. Okay? Only thing different between this and the last thing. What can't we divide by? 0. So the zeros in the denominator never can be included. Only difference. Otherwise, approach it exactly the same way. Okay? So what are the pieces up here that are going to make things 0? And? So, when is this guy 0? 0. X squared. When does x squared equal 0? When x equals 0. When is this piece equal to 0?
When it's
Negative 2. When is this piece equal to 0?
When it's -2.
When is this piece equal to 0?
When it's -1.
Negative 1. Told you, they look really scary, but it's the exact same process. They look super scary. Okay? Number line, smallest to biggest, -2, -1, 0. I'm going to make myself a little table. We're going to have our x squared. We're going to look at our x plus 2. And we're going to look at our x plus 1. So we've got a lot of pieces, but it's all built from these 3. All right, so we're going to fill in this table. If we have a number over here, is x squared going to be positive or negative? Is this one going to be positive or negative? Positive. Positive or negative? Positive or negative? This one. This one. Positive. This one. This one. Positive. And the bottom one? Negative. Then negative. If it's between -1 and 0? Positive. Positive. The hardest thing on this one to watch out for, which one of these terms is counted twice up here? The x plus 2. Okay? So is this one ever going to impact our multiplication if we have 2 of them? No, because it's always going to be negative times a negative. So we're just kind of going to ignore him. He's not involved in the thought process for the product. Oh, because there's 2 of them up here. Okay? Okay. Brianna. At the beginning of another one. Sweet. At the beginning of 4th period, you go down. Okay, so let's look at our products. So this middle guy doesn't really have anything to do with it because we have 2 x plus 2's up here. So when we're looking at our product, is this first set going to be positive or negative? Negative. Because this guy doesn't really help. He's not doing anything. This one, positive or negative? Positive or negative?
Positive.
Positive or negative? Positive. Okay. Are we looking for positives or negatives?
We're looking for negatives.
We're looking for negatives. So we're looking at these guys. Ooh, chunky marker. Holy cow. Looking at these guys. Which ones can't we divide by? The -2 and the -1. So we want everything less than -1, except we can't have -2, right? Because we can't divide by -2. So our solution, we're going to write it as -infinity to 2 with the parentheses, -2, sorry, and -2 to -1. There's one other piece that works that will make it equal to 0 since we equal counts. What else works? When does this guy equal 0? At 0. So this one actually counts. We can use 0 as well. So when we have these fraction-y bits, watch out for the random other values that count, because that one would also make it 0.
Yeah, why didn't we use the
Oh, because we have x plus 2 over x plus 2. So it's in there twice. So we would have like positive, negative, negative, negative. So we have 3 negatives there really. Positive, negative, negative, negative. So it cancels out. The x plus 2 is canceling out with itself. Okay. So just watch out for those things that have more than one repetition in there. What about the negative one? We can't have it in the denominator, because if x is -1, my denominator is 0. So that one doesn't count. Like, it cannot equal -1, because then I'm dividing by 0. So we got to watch out for the places where it's equaling to 0. We're going to try this again. Yes, we did not use the bracket because if it equals -2, what happens to my denominator? It's going to equal 0, and I cannot divide by 0, even if it has an equals 2 up at the top. That equals 2, only thing it changes for us on this one is that when that numerator equals 0 at 0, that's added in. So these are annoying and weird, but it's the same vibe. So let's look at our next one. We have x minus 2 over x squared minus 3x minus 10. So our numerator is already a factor piece. We need to factor the denominator. So we have x minus 2 over -5 and positive 2. So our factored form is x minus 5, x plus 2. And we want to know when this is greater than or equal to 0. So first things first is we need to find those zeros. Where are those zeros? Positive 2, positive 5, and -2. So we're going to look at all 3 terms at all 3 places. -2, positive 2, positive 5. Okay. Just give myself some more space. So we're going to look at x minus 2. We're going to look at x minus 5. And x plus 2. Okay. So if we have numbers that are smaller than -2, is this positive or negative? Negative. If it's between -2 and 2, is this positive or negative?
Negative.
Negative. If it's between 2 and 5, is it positive or negative? Bigger than 5? If it's smaller than -2, is it positive or negative? Negative. Positive or negative? If it's between -2 and 2. What's a number between -2 and 2? 0. 0 minus 5. Negative. Between 2 and 5. Negative. Bigger than 5. Positive. So for x plus 2, if it's smaller than -2. Between -2 and 2. Positive. Between 2 and 5. Bigger than 5. Positive. Do we have any of our terms that are counted more than once in our function? No. So we can just look at our product. Negative, negative, negative is going to give us negative, negative, positive.
Positive.
Positive, negative, positive.
Negative.
Positive, positive, positive.
Positive.
Are we looking for positives or negatives? Positives. Which of our n values are included in our solution? Which ones make it not work and which ones make it work? So our -2 and our +5 make our denominator 0, right? So this one we cannot use, and this one we cannot use. I'm going to do that on the top so that there's less gross. So I can't use the -2, and I cannot use the +5. So this one is included in our solution. Everything else gets parentheses. So if -2 is my x, what happens to my denominator?
Oh, 0.
It's 0. Bad time. If 5 is my x, what happens to my denominator? 0. If 2 is my x, my numerator is 0. Hunky-dory. And we have an equals to. So this one we can use. These two we can't. Okay? So our solution, yes, I know, I said hunky-dory. It's a very old phrase. It's not talking about Dory from Finding Nemo. So we can use the -2 to +2, but I cannot touch -2. I'm going to rewrite that so those are way clearer because those looked identical. Parentheses on the -2, bracket on the +2. Unioned with 5 with a parenthesis, because I can't use it, to infinity, which is an idea, so it still gets a parenthesis. Okay? We will practice more with these tomorrow. They're not, like, the only thing that's added in there is we're going to have one that, like, doesn't equal 0, so we're going to have to, like, do the adding of the fraction-y thingies, but it's the same process. Just here. Yes, as soon as I write it. All right, homework 2-7 only has 7 problems. I say, we know what that means though, right? They're longer. I mean, they're these. They're just these. Huh? Yay!